Hello and welcome to this third film in the series of films about solutions and concentrations. This one is about calculating the concentration of ions that are in a solution, and hopefully by the end of this film you'll know why it's so important that you know the formula of a compound if you're going to try and calculate the concentration of ions, and whether or not it's important to consider solubility. And you'll see a couple of example calculations. So here we go. Start off by looking at what formula has got to do with anything here. First of all, what we ought to be able to see by this stage, and if we can't, it's probably worth going back to the first film about solutions and reviewing that material, is that we've got three different types of substance here. Okay, here we've got an ionic substance, here we've got a strong acid, here we've got a weak acid, and here we've got something that isn't any of those things. So we ought to be able to spot that these are strong electrolytes, that this is a weak electrolyte, and that this is a non-electrolyte. Why is that important? Well, because only electrolytes release ions into solution. So if we're going to calculate the concentration of ions in a solution, we need to know whether there's any ions first of all. So there's going to be no ions here, so we're not going to have to do that problem. Similarly here, because we know that weak electrolytes do release some ions, but not very many, and we're not required to know how to figure out how many, we don't ever have to find the concentration of ions in a solution of a weak acid or a weak base. But you certainly do have to do it for strong acids and for ionic substances, because you know that they're strong electrolytes, and so all of their particles will split up into ions. So if you know how many particles there are to start with, you know how many ions there will be. However, it's very hard to know what ions there'll be if you can't remember your ion list. So once again, that is a really important thing to know, and if you still don't know it by now, go away and learn it, because it will make these kind of problems impossible if you don't know it. They're the ions in iron sulfate. What ions have we got in sulfuric acid? Well, we've got two H+ ions and a sulfate ion. So you can see that by looking at the formula and seeing what ions we've got, we'll be able to proceed in trying to calculate how many ions there are in the solution. And if we look at the difference between these two substances, we've got 2 ions in iron sulfate, but we've got 3 in sulfuric acid. So if I started off with 1 mole per litre solutions of these, so that's 1 mole of this substance is dissolved in every litre of solution, then I'll have 2 moles of ions here. So the concentration of ions would be 2 moles per litre, but in here, because there's 3 ions for every mole, I'd have 3 mole per litre concentration of ions. So you can see it's really important that you know what the formula is if you're going to try and calculate the concentration of ions that are around. It also might seem as though solubility would be an important thing to consider, because if you're going to figure out how many ions there are, you probably want to know how much of this thing dissolves. But what do we know about these two substances? Well, if you look them up on our data sheet, we can see that this one is called soluble, so greater than or equal to 0.1 of a mole of it will dissolve in every litre. Whereas this one's termed insoluble, so only as much as or less than or equal to 0.01 of a mole of that one will dissolve in every litre. Okay, so surely that's got something to do with the concentration of ions. Well, yes and no. Okay, if the question said, what concentration of ions have you got in 0.005 mole per litre solutions of both of these, then you could easily calculate that, because you can dissolve 0.005 moles per litre of each of these substances. But if it said, so you can do that problem, if it said, what concentration of ions have you got in 5 mole per litre solution of these things, well, this one doesn't dissolve that much. So you can't have a 5 mole per litre solution of it, so you can't do that problem. So in other words, if they're going to ask you about a solution with a certain concentration, then that concentration solution must exist. right? So in other words, solubility hasn't really got anything to do with it. So you don't have to worry about solubility when you're doing these problems, which is good. Here's a couple of example calculations to see how we can actually find the concentration of ions in solution. Remembering now the formula that we saw in the last film, which was that C equals N on V, right? So that is the concentration in moles per litre equals the number of moles divided by the volume. Remember, the volume must be in litres. Some of you might have already thought of the fact that you can rearrange this as well to find the number of moles, so N equals C times V. That's not that important in this problem. But anyway, it comes up in the next one. So let's have a look at what we've got here. We've got 0.25 moles of sodium sulfate. We've got 0.5 moles of magnesium sulfate. So once again, we need to know what the formulas of these substances are if we're going to know what the ions that are present here. Okay, so we've got sodium sulfate, Na2SO4, and magnesium sulfate, MgSO4. How do we know that? Well, because the sodium ion is a Na plus ion and a sulfate ion is an SO4 2 minus ion. And if you don't know your ion list, you can't figure that out. So there must be 2 of them to every one of them. Magnesium is a 2 plus ion, and as we've just discovered, SO4, and hopefully not just discovered, but reminded ourselves, sulfate is an SO4 2 minus ion, so we've got 1 of each of those in this substance. Okay, so if we now figure out how many moles of these things we've got, well, we started with 0.25 moles of sodium sulfate. So we're going to have 0.5 moles of sodium ions, this is twice as many, and 0.25 moles of that one. Okay, we've got 0.5 moles of this to start with, so we're going to have 0.5 moles of that and 0.5 moles of that, because there's 1 of each of them in that substance. Okay, add all these things together because we're trying to find how many moles of ions there are in total. So that's 1.75 moles. And we can go and do our C equals N on V calculation now. C equals N on V, which equals the number of moles, which is 1.75, divided by the volume, which is 0.5 of a litre. Remember, we've got to do this in litres, and there's 500 millilitres. Sorry, there's 1,000 millilitres in a litre. So that's 0.5 of a litre there. Okay, and that's simply double 1.75, which is 3.5 moles per litre. Now that problem was fairly straightforward because we're told the number of moles and we're told the volume of the solution. Okay. Moving on to a slightly more difficult problem where we're not told the number of moles of the substance, but remembering what we've just seen, that C equals N on V, and therefore N equals C times V, we can figure out how many moles of these two substances we've got, right? So here, the number of moles of HCl is 2, because that's the concentration, times 0.25, because that's the volume in litres. And here we've got 0.25, which is the concentration, times 0.5, which is the volume in litres. Okay, so that means we've got 0.5 of a mole of HCl, and we've got 0.125 of a mole of barium chloride. Oops, so I've kind of crossed it out there, but you can remember what's there. If I delete it, I delete everything. So now we need to know what our formulas are. Well, we're told that formula, so we've got H plus there, and we've got Cl minus in it, 1 of each, so there's 0.5 of a mole of that one, and 0.5 of a mole of that one. Barium chloride, however, we need to know its formula. It's Ba, which is 2 plus ion, so it's got 2 chloride ions with it, so we've got a Ba2 plus ion, and 2 Cl minus ions. So in other words, we've got 1 of them, so 0.125 moles of barium, but double that amount of chlorine, so 0.25. Add all these numbers together, and we've got 1.375 moles. That's the total number of moles of ions. Remembering that the concentration is N on V, we can now say that that is 1.375 divided by the volume, which is 250 plus 500, so 0.75. Let's just quickly plug those numbers into the calculator, see what they are. 1.375 divided by 0.75, and that's 1.83 moles per litre. Okay, so two different types of calculation there. One slightly simpler one where we're given a bit more information. This one here where we've got to actually find some things out for ourselves using the formulas that we've started to look at. Okay. The most important thing with these calculations, really and truly, is making sure that you feel confident with them. If they're hard, you're probably not ready for a test on them, so come and get some help with them. Okay. If you're comfortable with this, then move on to the next film, and that is film 4, which is about dilution problems.